So in this question, we've got a ball is being projected vertically upwards at u meters per second from the point X, which is 2.5 meters above the ground. Then as it fires up, it reaches a maximum point of 150 meters above the ground, which is point Y. We need to find the initial speed and the time it takes to hit the ground. So i.e. it fires up, and then comes back down and then hits the ground. So first of all, let's just draw a diagram of what's going on. So the ball is fired up from point X, 2.5 meters above the ground. So let's just put the ground here, 0 meters. I just call that 0 for the ground. So that's where the ball is. And it's fired up to 150 meters, point Y. So if I call that Y, 150 meters, the ball fired up to this point. And when it's reached this point here, that's its highest point, it then will fall back down to earth and comes back down and will land in this position. That's its final resting position. So we want to find the initial speed. So we need the speed at this point here. So as we've got u meters per second, we need to find initial speed and time. This is going to be a classic SUVAT kind of question. So I've got S, my displacement, U initial speed, V the velocity, A the acceleration, T is the time. Time, I don't know, let's work that out later. Acceleration, well we can work that out because the acceleration due to gravity. So the ball is going up this way, but acceleration due to gravity, that is this one here, which is going in the opposite direction because being forced back down onto the ground. So acceleration is 9.8 meters per second squared. So we've got minus 9.8. Okay, velocity, we can just put a 0 in for that one. And u, that's our velocity, our initial velocity, that's what we want to find. And the displacement, we know is from this point to this point using that initial velocity. So it's travelled 147.5 meters. So 147.5. So we're not interested in time at the moment because we want the initial speed. So we need SUVA. So SUVAT equations with those three values in, and then we can solve for u. Well, the one we can use for that is v squared equals u squared plus 2as. Now the velocity at this point is 0 because it's stopped. So we can fill that in, 0 squared. And the initial velocity we don't know, that's what we want. And then we've got 2 times the acceleration times the displacement. So 2 times the acceleration times the displacement of 147.5. Okay, well, if we bring, this is going to be a minus, so let's put this onto this side and solve for u squared. So then I've got 2 times minus 9.8, so that gives me 19.6 times 147.5 equals u squared. Okay, now plug that into the calculator. I'm going to get 53.768. So that's going to be my u for my initial speed. So 53.768 meters per second. So initial speed, u equals 53.768 meters per second. So that's our initial speed at this point here. So that takes care of the first part of the answer. Now we need to know how long it takes to hit the ground. So now we need to use this one here. Now what we can do with that one, we've got our initial speed, which is now 53.768. We've got our acceleration, which is minus 9.8, so that's still minus 9.8. We need to find the time, and what we need to do now is have a look at the displacement. How far will the ball have travelled when it hits the ground? Well, we know it's gone up and then back down, but it's only travelled 2.5 meters, and the 2.5 meters is down, so it's going to be minus 2.5. Okay, now the velocity, we're not worried about the velocity at this stage because we've got our initial velocity to help us out with that one. So now we need an equation with SUA and we need to find T. That's what we need. So the SUVAT equation that's going to help us out with that one is displacement equals initial velocity times time plus a half times the acceleration times time squared. So we've got all these here except the T, so we can solve for T. So we've got minus 2.5 equals U, which is 53.768 T, plus a half times the acceleration. So a half times minus 4.9, and then that's T squared. Sorry, that's minus 9.8. The answer is minus 4.9, so minus 9.8. So let's simplify this one off a little bit. So let's get everything over to this side. Let's do that. So I've got 0 equals 2.5 plus 53.768 T, and then minus 4.9 T squared. Okay. Now we can put that in our calculator. We'll get two results. We'll get one that gives us a result below 0. So either T equals, I think it's 0.05-ish, so it's approximately, or we'll get T is approximately 11.02. So that's our two results if we solve that and put that in our calculators. So therefore the time for this ball to hit the ground from its initial velocity and coming back down is 11.02 seconds. So time to hit the ground is 11.02 seconds, and that's to 4 significant figures. So that's an S and that's a 2. Okay. So that answers our question on this ball being fired up from the ground. Okay.